Hello, everyone. So, until now, we have covered three different topics. First is prefix sum, okay, under which we have already covered prefix sum using map. Then we have sliding window, and then we have cadence algorithm. All these three topics are related to the subarray itself, as we have seen. Not prefix sum fully, but one topic under prefix sum, which is prefix sum using map, is related to subarray sum. Then sliding window is again related to subarray questions, and then cadence algorithm is again related to the subarray related questions. So now, when to use which type of method is the biggest question now. Okay, so when we will use prefix sum using map, when we will use sliding window, and when we will use cadence algorithm. So this short video discusses upon what you need to use on which type of question. So we'll basically see the difference between all these three and when to use what. So first we'll go through prefix sum using map. If you have not seen this three, I would literally suggest you to go through this three videos, this three playlists, okay, and then only you will be able to compare when we can use what. This is the reason I have made this comparison video at the end of this three playlists. Fine. So if there is some condition, if condition on sum of k is given, then we can use prefix sum using map. Then we can use prefix sum using map. So if condition is given on sum of k, what condition? Condition is given on sum of k. Okay, it will be given on sum of k. So there is directly or indirectly. This could be directly or this could be indirectly. Fine. So I could write it that directly or indirectly. So it's mentioned implicitly in the question or explicitly. You need to derive it from the question that okay, the condition is given on sum of k. Okay, and those type of subarrays you need to find where this condition satisfies. Then prefix sum using map will be used. Okay, second thing, values of the array could be both positive and negative. Okay, there could be both possibilities. The values in the array could be both positive and negative. Okay, questions are related to finding out questions are related to finding out minimum length or maximum length of subarray satisfying this condition, or total number of subarrays satisfying condition. Which condition? Condition will be always on the sum of k. Condition will be always on sum of k. So please remember this, sum of k is the condition. Okay, so there could be some condition like okay, you need to find the subarrays with maximum length such that the sum is equal to target, or such that the sum is equal to 0, or such that there could be equal number of ones and equal number of zeros. So that means you will convert those zeros to minus ones, and then that sum could be 0. So this you have made the condition related to sum of k. So when this type of cases are given, prefix sum using map will be the best option, and you will always solve this type of question using maps as it says in the topic itself. Okay, so we have already learned. If you didn't know, you can go and watch out those videos. Fine. Let's move to our another section, which is nothing but sliding window. So if condition k is given, okay, see I have not returned sum. If some condition k is given not on sum of subarray, okay, this doesn't mean that the k condition is necessarily on sum only. No, it couldn't be. So if some condition k on is given on subarray, or substring could also be possible in this case, or substring could also be possible in this case, then use sliding window. And another question, another point also I would mention, if condition on some k is given, then the condition would be like at least or at most sum of k. Okay, it shouldn't be exact sum. Prefix sum using map will only be followed when you are given fixed exact condition of k on sum of subarray elements only. Now, when some different condition is given, okay, that doesn't have any sense or relation with sum or addition of the subarray. Like it could be like, okay, um, the total number of vowels in the subarray could be equal to 2. Okay, so that there couldn't be any relation with the sum of this. Okay, or that could be like, okay, the frequency of A, B, and C could be 3 in this case. So this is not related to sum of elements at all. Okay, if this type of conditions are given, or you have to choose maximum consecutive cards such that any two cards are same. We have seen those type of questions. I'll be giving you example after this. Okay, of every question, like, okay, what type of questions are given and how it is satisfying to the rules which we are mentioning now and currently. Okay, and if at all the sum of k is given condition, then that condition would be that sum of the subarray could be at least 8, at least 5, or at most 8, or at most 5. So it could be at least or at most based conditions. Then we will use sliding window. Another thing is, value of array could be only positive or only negative. It couldn't be the mixture of both. Never. It could be only positive or only negative. Then only you can do this type of questions. Fine. And mostly questions are related to what? Finding the same maximum length or minimum length or total number of subarrays. It could be the same. Okay, mostly the questions are related to finding the maximum length, minimum length, or total number of subarrays satisfying that condition k which is given. So this is our sliding window. Oh, sorry. Clear? Now we come to Kadane's algorithm, which we have learned recently. Fine. So Kadane's algorithm, uh, if the question, first thing, there is no fixed condition k. There is no fixed condition at all of k. Okay. And the question is related to finding out maximum sum or minimum sum subarray. So the question is framed in might be different way. That, okay, as we have seen in the last video of Kadane's algorithm, that it could be like, okay, you need to find the maximum absolute difference. Okay, then we have seen that, okay, we will take the maximum one subarray with maximum sum and another subarray with the minimum sum, and then we could do that uh, difference. So indirectly it comes to finding out the maximum sum or minimum sum subarray, then that could direct us to Kadence algorithm problems. There is no fixed condition k, and another thing is, value of array could be both positive and negative. Then we will use Kadence algorithm. As we have seen, question is related to finding out maximum sum or minimum sum subarray. So you will return the maximum sum and minimum sum. In this two type of problems, we'll always return lengths. Okay, here we will return the sums. I hope you got it. So without wasting time, let's move to the questions, how the questions are. Fine. So this is the first question. So the question says, you are given an array nums and an integer target, and we need to return the maximum number of non-empty, non-overlapping subarrays such that the sum of values in each subarray is equal to target. This we have either solved it in our classes, in our videos, or I should have given it in the description for your practice. Okay, I have chosen it from there only. And one of the example I could write over here is this. Let's say the nums is this and target is this. Okay, so first thing you will notice is both positive negative values are given. It could be either prefix sum using map or cadence algorithm. Now what is given? That nums is given, one target is given, and we need to find the non-overlapping subarrays. So the total number of subarrays. Okay, one extra condition is non-overlapping. So we also need to maintain some index to verify that it's non-overlapping. But we need to find total number of subarrays which satisfies sum of values in each subarray is equal to target. So in which category it is falling? Of course, first category. So condition on sum of k is given. Okay, values both positive, negative. We are finding the total number of subarrays. So this will fall under prefix sum using map. So we will solve it under prefix sum using map. I hope you got it. Okay. There could be another question like this. Fine. So you are given an array containing integers and an integer k. Two things are given, an integer array and an integer k. For better explanation, let me give you this example. Your task is to find out the length of the longest subarray where sum of its elements is equal to the given value k. Again, some fixed k condition given that sum should be k, and we need to find such maximum length subarray. So maximum length of subarray having sum equal to k and both positive and negative values are given. Of course, we will do what? Prefix sum using map. Clear? Prefix sum using map is the only option we have to do here. Now there could be another questions. Uh, Let me give you another question which says, fine. Let's say this is the question which is given. This also we have already solved in our regular video itself. The score of an array is defined as the product of its sum and its length. So for example, the score of 1, 2, 3, 4, 5 is the sum of it into the length of those subarray, which is 5, which is 75. Given a positive integer array nums, so it is clearly mentioned that this is positive. So now it could fall under any of those three, because it is positive integer nums and an integer k is also given. Okay, so some condition k is given, so Kadane's algorithm could not be possible as far as we know. So it could be either prefix sum using map or sliding window. Now let's see what is the condition. We need to return the number of non-empty subarrays, so we need to find the total number of subarrays whose sum is whose score is strictly less than k. So score doesn't mean sum over here. Score doesn't mean sum over here. Score is what? Sum into length, product of sum and its length. Okay, let's say we could do that with prefix sum using map also. If we could know the length, sum multiply length could be possible at some point. But still, it is not fixed or exact k sum. It should be strictly less than k. So it could be anything less than k. It's not exact k. It's not exact k. So what we will use here? What we will use here? We need to find the total number of subarrays which fall into this. Only positive. Okay, sliding window could be possible. Some condition k is given, okay, which is not exactly related to sum only. It is sum into product. The the condition is sum into product should be less than k, and it is not exact k also, less than k. Okay, so all this is referring to what? We can use sliding window in this case. So we'll go with the sliding window approach in this type of problem. Clear? Um, there could be another problem. Mostly substring related problems goes under the sliding window only. Fine. Mostly the substring related problems also goes under the sliding window point. Now let's say we have this another question which says that the frequency of element is the number of times it occurs in an array. Okay. You are given an integer array nums and one integer k. In one operation, you can choose an index of nums and increment the element at that index by 1. Okay, what you can do is you can choose one index, you can increment that element of index by 1. We need to find the maximum possible frequency of element after performing how many? At most k operations. So of course we can increment it to maximum number in that subarray only. We have solved this question also in one of our video as far as I remember. Okay, so what we can do is we are given, let's say, this nums, and we can perform at most 5 operations. Cool. Let's say I choose this two, 1 and 4. Then I can increment 1 to 3 times. So I can use 3 operations and I can make 1 also as 4. So maximum possible frequency is 2 of 4. Or I could make 4 to 8, then that could be also 2. Fine. We need to return the maximum possible frequency. Now here the condition k is given, but anyways it's at most k condition. Okay, numbers are also positive only. It's not mentioned here, but in the constraints mentioned, it is given that numbers and the values are positive. And also, the condition on k is not related to sum of the subarray, addition of the subarray. It's some different condition only. It is related to the total number of operations. Okay, it's not at all related to sum. So of course, we will use a sliding window in this case also. Clear? And cadence algorithm falls under very simple category where you'll be just asked to find maximum sum of subarray or minimum sum subarray, or the modified version will also be like, okay, we have done in the last video. I'm repeating that maximum absolute difference you need to find. So how can maximum absolute difference would be find between two subarrays? If one subarray is maximum sum and another subarray is minimum sum, and that too we have to done non-overlapping. So we have done prefix of I, or left max of I, right mean of I plus 1, right max of I, left mean of I plus 1. So if you have not watched that video, I'll strongly suggest you to watch the last video of cadence algorithm. So if maximum sum subarray or minimum sum subarray related problems comes, it's going to be cadence algorithm only, because for sliding window and all this case you will need some condition. Okay, now all these three all these three have fixed time complexity of what order of n. All these three algorithms takes order of n time complexity, and now all your subarray related problems will be solved. All your subarray related problems could be solved with these three algorithms. Now it is depending on you. You choose which algorithm. Choose your algorithm wisely. Depending on the question, I have made it very easily when to use which algorithm. Just remember this 3-4 points of each algorithm. Okay, and you are done. If you choose your algorithm wisely, then all sub-array related problems, two-pointer related problems will be easily solved. Clear? I hope you got my point. Okay, so I'm done with this video for today. Stay tuned for the next video. I'll be covering something new on basis of these three algorithms. Now we have to use this three, and we have to go for 2D matrices. So this is all we have done until now for 1D array elements. Okay, this all we have done is for nums array or array as the 1D array. Now we're going to see for the 2D array all these three. How could they work? So stay tuned for the next video. Do like and subscribe and share it with your friends if you have learned a lot of out of it. Okay, stay tuned, stay safe. Bye.